server side, right? So as you can see, the project structure, it runs on a microservices architecture, right? So we have your backend, your front end, your GitHub, which is very important as well. But let's just go to the backend for now, and then I'll come to the GitHub implementation as well. So we have your source. What are we looking for? We're looking for the server .javascript file, right? Which I've already opened here. So I'll just go back there. Then I'll go to the top so I can make you understand the security measures that we do. This happens before the data goes to the database, right? So let's just get to it, right? So we have the helmet or security headers. So this protects in case was your XSS, your clickjacking, etc. attacks as per the marking rubric. So I've implemented this as per marking rubric, right? So helmet, so it's protecting against all other attacks. So this is very important. Your helmet and your security headers, right? And then we have a rate limiting protection against brute force as well as what DOS. This is very limited, right? So what if you have, for instance, you have used that there's too many requests to the IP address? That's very dangerous, because that may mean that they want to actually maybe crash the system or implement an attack to the system. So if you have like 15 minutes window, right, to have your all everything there, then if you have too many requests, then it's like, no, please try again. Then we have a rate limiting, right? So we have only 10 attempts to log in per 10 minutes, per 15 minutes, I mean. So if you have too many login or register attempts, you're gonna have to try again later. So this is very important. So what's that? Your rate limiting to what, to protect against brute force as well as DOS, right? Then here you have your CRS. Then we just come to your password security. As I've said, here we are including what, or we are using your Agent2 ID, which is recommended as per the industry standard. What does this have? High memory cost for strong protection, and it is the 64 megabytes with what, with 4 iterations. So a password security, Agent2 ID, we use it for what, for hashing. Then we are able to verify the password as well, which is very important. Then here we have input whitelisting, the irregular expressions, right? So as you can see over here, we have constant patterns. You see, for each field that's in the application, as you might remember, right? The login has what, or the registration is username, email, and password. Login is email and password. Then the rest of the page, which is the payments page, is what, all these fields. So each field has its own regular expression, right? That means every field must have what, an input whitelisting, which is very important, right? Then we have the route. If the user already exists, I think I've already shown you that. If the user already exists, you are routed back to what, to the login page. You can't log in twice, you can't register twice. No, you can log in twice basically, but you can't register twice, right? And then, because this is time sensitive, that's why I'm talking so fast. And then we have the payment full white listing as well, and I'll also attach this project as part of the submission so that you can also use the same. So as you can see over here, everything is perfect basically. Now this is where what you would store everything into the database, but what have we implemented? We're using map, so everything is stored what, on the web browser itself, since we don't have any requirement to what, to store data into what, into a database. Now I'll just go to what's this, DevSecOps, and then I'll go to the conclusion.